Hello again, this is variability, excuse me. Hello again, this is variability part 2, which will cover the calculation of statistics for variability that can be used not only for descriptive statistics, but for inferential statistics. So far, we've talked quite a bit about various statistics to capture central tendency, including the mode and median, and statistics to talk about spread, including, for instance, the interquartile range, the semi-interquartile range, the 5-number summary, and the box plot. However, what we haven't seen in detail are the statistics that we will need to move into inferential statistics, move beyond describing and communicating data, but making inferences about sample data to population parameters. So for these inferential statistics, we really need the mean for our measure of central tendency. We can still use other statistics to describe, but for further calculations, we'll be using the mean. And to describe spread, not describe spread particularly, although the standard deviation is also descriptive, but to perform inferential calculations about that involve spread, we'll need the variance in the standard deviation. So remember that the mean conveys central tendency and the variance and standard deviation convey spread. The variance and standard deviation convey spread from the mean, not spread from the median, which is related to the interquartile range, for instance. In a normal distribution, the mean, the median, and the mode are all the same. So a normal distribution will have mean equal median equal mode. All three will occur most frequency, where the y-axis is frequency or frequency percent. But in skewed distributions, whether a positive skew or a negative skew, whether we call that right skewed or left skewed, the mode, the median, and the mean are not equal. And in particular, the mean tends to go up in the direction of the skewing outliers relative to the mode and the median. So our mean is particularly important in statistics involving the normal distribution or based on assumptions of the normal distribution, because it conveys all information about central tendency. So we're going to review a bunch of calculations, starting with review of the mean. And here's the fancy formula for the mean that includes the super notation and subnotation. But the main things to remember is that the mean is x bar. What it's calculated from is the sum of all the cases in the distribution divided by the number of cases in the distribution or the sample size. So it's the first case plus the second case and so on through to the nth case divided by n. And so here we have 1, 2, 3, 4, 5, 6, 7 x values. And if we add them all up, it's going to be 2 plus 5.2, et cetera, et cetera, et cetera. And the sum will be 36.1. And we will divide by 7, and that will get us a value of 5.1571. Now you'll notice that that's what we call, say, to be at a level of precision that is well beyond our base variables or base variable, which only went to the tenths place, whereas this goes to the 10,000ths place. So that is generally a rounding rule, is to round at your final steps at the level of precision found in the original data. And the rounding rule that we're using is that when the value before the level of precision, so the level of precision would be the tenths place, when the value is 5, you round to the nearest even number. And that 5.2 is your mean. When your calculations, if you are using something like a spreadsheet or a calculator that retains values, you're better off not rounding. I recommend you not round until the final step, because if you frequently round at intermediate steps, you will enter in quite a lot of rounding error eventually. But depending on your access to and comfort with technology, that will probably vary among you. So now we're going to go into some things that we haven't worked on the calculations of, particularly in class. And those are the steps to get to the variance and standard deviation. And the first step to get to the variance and standard deviation is what's called a deviation score. So each deviation score is the individual score of a case in the data set on a particular variable minus the mean of all cases in that sample. And that is typically denoted with what I will call little x, which is a small case italicized s. And the I there just means, as it's meant before, for any particular case in the data set. And so when we have these values that begin, we've already calculated the mean. Our next step to move towards the statistics that can be used in the future for inferences about from the samples to the populations is to get these little x's or deviation scores, x minus the mean. I write mean here this way instead of x bar, which I do that way simply because I couldn't figure out a way to put it into a spreadsheet. But each little x, for instance, negative 3.2, is the original x, 2, minus the mean. So 2 minus 5.2 is negative 3.2. 5.2 minus 5.2 is 0. 1 minus 4.2 is 5.2 is negative 4.2, and so on. Now, when you're calculating your deviation scores, you can and should check, because the sum of deviation scores should always be 0. So our next step is to square each deviation score. And this term here, the squared deviation from the mean, doesn't have any name to my knowledge. It's just for a score, it's deviation, so the deviation score squared. Deviation squared, each individual score. And so we square negative 3.2 and we arrive at 10. Notice that any value that's negative, the square of negative value is always positive. So the sum of all these will always be positive. And if you create these and any of them are negative, you have made a mistake. So that's something to watch out for. So once you have got each of those, you sum them. And now we have a term that actually has a name, which is the sum of squares. And that is the sum across all squared deviation scores from when those deviation scores are based on deviations from the mean. So this is the sum of all of these. It's called the sum of squares, SS, and its long fancy name is the sum of squared deviations from the mean. You will very frequently hear it referred to as sum of squares, and its typical abbreviation is SS. Once you have the sum of squares, you can now get to the variance. Oops, sorry. Okay, you can now get to the variance. So the variance involves taking the sum of squares and dividing by n minus 1. So we had 7 cases, n minus 1 is going to be 6. And this is a sample statistic, and it's important that it's a sample statistic. You can actually get the population variance, which does not subtract 1 from the n. But because we're looking forward to inferential statistics, we want to use n minus 1, which is called an unbiased estimator of the, well, it's adjusted for bias in the population value of the variance so that it's a better estimator of the population variance. Not something you particularly need to know about. Just to say that again better, when you're calculating the mean of a sample for the purposes of inferential statistics, you do not divide by n minus 1. That's because there's no adjustment needed to make inferences from a sample mean to a population mean, because the sample mean is considered an unbiased estimator. The sample variance, in terms of its functionality to estimate the population variance, is not unbiased. So you adjust its formula by what are called degrees of freedom. You lose 1 degree of freedom every time you calculate, for instance, a mean. So we've calculated the mean once, so we've lost 1 degree of freedom. So that's why n is subtracted by 1. Okay, that was long-winded, but really kind of just for those of you who care. Pretty optional conceptual knowledge for this class. So you've taken this, you divided it by 6, and you have the sample variance, which will usually be written italicized s to the power of 2 or squared. And then you can go from the mean to deviation scores to the sum of squares to the variance, and then finally to the standard deviation, which is the square root of the variance, square root of the variance. This is pretty much fully broken out formula where you can see all the parts of it. The mean, the deviation of a score from the mean, the squaring of the deviation of the score from the mean, the sum of all those squared deviations from the mean, the kind of adjusted average of all the squared deviations from the mean, and then the square root. So that's the linear move trajectory from the mean to the standard deviation. The interpretation of the standard deviation, besides the fact that you will note that the only place really where you can count on, well, the standard deviation is on the same scale in terms of units of measurement as the original x's. So the variance will not be, you can't count on it to be. Sometimes variances can have explosive values due to the magnitude of each original value and what happens to it when you square it. So a variance can be very large and transparently not on this scale. But 3.67, so if these were inches, okay, very simply put, if these x values were inches, 3.67 is measured in inches. If these were points on a scale that goes to 15, from 1 to 15, these are points in reference to the same scale. If these are pounds, 3.67 is measured in pounds. Otherwise, interpreting the standard deviation can be difficult depending on whether or not the distribution is normally shaped, but we will continue with that another time. In the meantime, I'm going to show you how these steps are done in SPSS. So we have our data in SPSS now, variable 3. We only have 7 cases, so all the other cases are just missing on these data. And this is going to be a very brief section of the video because it requires very little to perform this calculation. You will not get deviation scores or squared deviation scores with these calculations that you do in SPSS. All you can request are the variance and the standard deviation, as well as other things, well, and the mean, as well as other things that we've seen previously, such as the interquartile range, the which is available under Explore, the quartiles, which is available under frequency statistics, and other things of that nature. As I have said before, there are multiple ways to obtain various things in SPSS, way more than I'm going to demonstrate here, but I'll just show you a couple of places. They are all under Analyze, and under descriptive statistics, you can actually get them under other things, but we're just going to look at, I believe, 3 ways to get them under descriptive statistics. So the first thing is I just reset. So I had previously had variable 1 clicked over to the variables I wanted frequencies on, and I could have clicked it back, but instead I completely reset, so I would just start from scratch. So I'm going to look for variable 3. I'm going to ask for statistics on it. I don't want the quartiles or the percentiles. I want the mean, the standard deviation, and the variance. Very simple. And I remember in this case to uncheck display frequency variables, since this is a continuous variable. I don't want those values. And I will get 5.1571. I note that these have not been rounded, but they match our prior value. So you can go back and check that if rounded, these would match our previously calculated variables. I just took a little pause and went back and checked our calculated values. They all match, obviously, or perfectly. However, I do note that I forgot to round the standard deviation to the same level of precision as the original variables. So that's my bad. All right, so there you've got your numbers. You want to explore a couple of other ways to get them. You can get them under descriptives. So I'm going to I didn't need to reset that. We did it under frequencies. Now I'm going to do it under descriptives. And without having to go any further into descriptives at all, I will get the mean and standard deviation. The descriptive statistics command will not get me the variance. However, I can just square the standard deviation if I want the variance. And typically, if you just want to report the descriptive results, and you always do want to report these 2 results, they're considered minimum essential statistics or something of that nature. I can't quite remember the phrase, but They are should always be reported with quantitative analyses. But because the standard deviation is the square root of the variance, you can always derive the variance by squaring the standard deviation. And the third way I'll show you is under descriptives again, under explore. As I said, I like this explore. Explore is much more useful if you have multiple variables that you want information, or if you want a whole lot of information. But in this case, I'm only going to ask for statistics, and I'm going to ask for the descriptives. But as you saw in a previous video, you get a great deal. Note it says that you're missing all these people, and that's because these are really two completely different data sets. So we're not going to pay attention to that. But the mean is, as we rounded, 5.2. You see a variety of things having to do with this. What's the standard error of the mean? Trimming the mean for the presence of possible outliers. The median, here's the variance that we obtained. We rounded to 13.5. Here's the standard deviation that we obtained. It also, again, tells you minimum, maximum range, interquartile range. And these have relate to the shape of the distribution, and I advise you not to pay attention to them at this point in the course. The very last thing I'm going to do for this video is I'm going to show you how to export your output in ways that make it easily retrievable in the absence of SPSS. So there are two easy ways. One is to export as a web report, which will give you an HTML file. And I'm just gonna put this on my desktop and call it variability. And another that I like is to export. Just click that, and it gives you a lot of ways that you can export. So I usually export only the visible stuff because there's a lot of stuff that is in output that you can't see. It has to do like how much time something takes to process. And I don't really want that stuff. You can export as a PDF. You can export as a PowerPoint. Some of these things are new. A lot of times I will export in RTF format because it's easy to manipulate. So I'm going to do that. I am going to put this also on my desktop, and I'm going to name it variability. I hope you've been seeing all of those things. And now I'm going to pull this stuff out. And here you can see my crazy desktop. And where are these files? My desktop, I usually keep it so nice, but I've been so busy. Where are these? Here's variability as an HTML. Sweet, huh? Oh, sorry. You know, it's just like, okay, here's the log of what I did. I asked for frequencies on that variable. Here they are. I asked for the mean, standard deviation, min and max. Here's where they are. I did explore, the case processing summary, and my descriptives. So quick. This is a relatively new addition to export. Now, it's not graphically manipulable except by using like snipping tools and things. So another thing that I like to do, if I can just locate it. I wonder if I failed to save it on my desktop because I'm not seeing it. So Okay, my apologies for that. I was searching desperately for this RTF document, which I kept saving in strange destinations, but I found it now. So we'll just take a little quick look at this document and be done. And so you see, here it is. You can save this as a Word document, and I saved all visible format, all visible. See, look, if you save all visible output, this is what you get. I get where it is, I get how much it weighs, who knows what that is. All right, and I'm going to go through these things. But here are my descriptives, and the nice thing about this is if you double click on them, they're editable. You can even get rid with some, it's slightly tedious, but you can get rid of rows. You can copy stuff into Excel. It's much better format for making tables because you will see eventually on your first mini project, but I'll slap you around metaphorically if you turn in tables directly copied from SPSS. And so I'll expect you to make APA tables. So one way to convert things from SPSS to APA type tables is to first get things in format that's manipulable, and then you can start to work on them and get them in the APA format. All right, I believe we're done. Enjoy whatever day or night you're in, and I'll see you next time.